Hi, welcome to Misty's Math, your 9709 exam specialist. Now this video doesn't cost you anything, but perhaps for a support, you can click the subscribe button.
Hi! So today we're going to look at a specific topic on probability and statistics 1, which is probability distribution table. Right? So I have selected latest questions for us to discuss today. What you can do is, maybe if you would like to try before I discuss it, you can take a screenshot, pause the video, and work on it first. You can come back to the video and check your answers later on. Altogether, I'll be showing you 4 questions that we are going to discuss. My first paper here is taken from March 2025. This is question paper 5.2. You can take a screenshot, try it on your own first. Now, if you're ready, let's look at the question. So Jacob throws 3 coins at the same time. The first coin is biased, so that the probability of obtaining a head when it is thrown is 1 per 3. Getting a head is 1 per 3. The second coin is also biased, so that, I had a typo here, sorry, so that the probability of obtaining a head when it is thrown is 1 per 4. So again, getting a head, it's 1 per 4. The third coin is also biased, so that the probability of obtaining a head, another head, is 1 per 5. So, random variable x is the number of heads obtained. So show that probability of x equals to 2 is 3 over 20. Px equals to 20 means that probability of you getting 2 heads. Now think about the situation which can give you 2 heads. I can get 2 heads when I have, from the first coin, head, second coin is also head, the third coin is a tail. Or I can have, first one is head, second one is tail, and the third one is another head. Or I could also have the first one showing a tail, second one showing a head, and the third one is also showing a head. So these are the 3 scenarios that is possible for me to have 2 heads. Now let's look at each of the situation. Our first situation here is head, head, and tail. What is the probability of me getting the first one to be head? It is 1 per 3, right? Second one to be a head is 1 per 4. And third one to be a tail. Now, you see the probability of us getting a head is 1 per 5. Means that the probability of us getting a tail for the third coin is going to be 4 over 5. Okay, I'll leave the computation for later on. Our second situation is having head, tail, and head. What is the probability of me getting a head on the first coin? It's going to be 1 per 3. What about getting a tail on the second coin? So getting a head is 1 per 4. Getting a tail must be 3 per 4. Okay, and then what is the probability of me getting a head on the third coin? It is 1 per 5. Okay, next situation is having tail, head, and head. What is the probability of me getting a tail on the first coin? So getting a head is 1 per 3. Getting a tail must be 2 over 3. Right? And then getting a head is 1 per 4 on the second coin. Getting another head on the third coin is 1 per 5. So let's do the computation. This is simply calculator works. It should give you 4 over 60. This is 3 over 60. And this is 2 over 60. If you add them all together, you should be getting 3 over 20. And you get the exact value that you have to show, that is 3 over 20. How do you get marks on this? You will get the mark when you are showing that you are multiplying and you are adding them. And the order of the coins must be consistent. That is basically an independent mark B1. You are not getting any mark for the final answer because 3 over 20 is given in the question. I'll move on. Question B is asking you to draw up the probability distribution table for x. Now think about this. You are tossing 3 coins and x is the number of heads obtained. What is the minimum number of heads you can obtain when you toss 3 coins? I'd say let's work on it this way. So I'll show you what do you need on a probability distribution table. You will need the number of x. And for each of those x, you will be needing the probability of x equals to x. Meaning to say, if my x is 0, underneath 0 is basically the probability when x is equals to 0. Right? If my x is 1, underneath of 1 is probability of x when it is equal to 1. Okay, and so on. So again, let's think. What is the least number of heads you can have when you toss 3 coins? Let's say the least number is 0, right? You can have everything showing tails. Can you have 1? Yes, you can have 1. Can you have 2? Yes, you can have 2. Can you have 3? Yes, you can have 3. Can you have 4? No, because maximum number of coins is just 3. It's not possible for you to have 4 heads, right? So you have there 0, 1, 2, and 3. What is the probability of it showing a 0? As what I mentioned earlier, is just when they are all showing tail, tail, and tail. And the probability of this happening is basically 2 per 3, right? That is a probability of you getting a tail for the first coin. Getting a head is 1 per 3, getting a tail is 2 per 3. What about getting a tail on the second coin? It's going to be, 3 per 4. And getting a tail on the third one would be, getting a head is 1 per 5, getting a tail must be 4 per 5. Okay, computing this, you should be having 2 per 5. I'll write it here. What is the probability of you getting 1 head? Getting 1 head means that you're getting head on the first coin, second and third are both tails, or tail on the first one, second is a head, third is a tail, or first one is tail, second one is also tail, and the third one is a head, right? And what is the probability? You have to work it out like what we did in question A. So this is going to be 1 per 3 times 3 per 4 times 4 per 5. THT would be 2 per 3 times 1 per 4 times 4 per 5. And TTH would be 2 per 3 times 3 per 4 times 1 per 5. Okay, and you just have to compute everything. You should be having here 12 over 60. You are going to add with 8 over 60 and also 6 over 60. So all together, the probability of you getting x equals to 1 is 26 over 60. What is the probability of you getting 2 heads? It's given earlier, which is 3 over 20. Now, what's the probability of you getting 3 heads? 3 heads is when everything is head. So it's basically 1 per 3 times 1 per 4 times 1 per 5. Okay, you'll get the 1 over 60. I'll write it here. There you go. How do you get marks on this question? You'll get the first mark when you have a table with correct values of x, which is 0, 1, 2, and 3, and at least one further non-zero probability that is correct. So if you have 0, 1, 2, and 3 on your x, and one of the probabilities correct, you will get your first mark, B1. Second mark is when you have one more correct non-zero probability which is linked to the correct outcome, which for me, I got it here, and that is a B1. The third mark, the last mark, will be given when you have all 4 probabilities correct, and that is B1. Altogether, 3 marks. Now let's move on to question C. Remember, if you want to try the question before I discuss it, you can always take a screenshot and work on it by pausing the video first. The question C is asking you to work out the variance of x where you are given the EX is equal to 47 over 60. This is a popular question. I think you will always see this kind of question every year. Remember that to work out a variance of x, you just need to find out the summation of x squared times p. In our table, we're basically having x to be 0, 1, 2, and 3. So remember, you need to square it first before you multiply with each of the probability, and then you have to sum it up. Don't stop there, because afterwards you will need to subtract with the mean. The mean is basically the summation of x times p. This one is before you square the x. You just straight away multiply with the probability, and this value should be squared. Okay, remember I mentioned to you summation of xp is just the mean, or can be written as EX. Okay, which in our situation the EX is given to us. So let's work it out. Summation of x squared times p. So when you have x to be 0, 0 squared is 0, times with 2 per 5. I would suggest you to still write it down as part of your working. You will need to add this with x is 1, 1 squared is 1, times with the probability, that is 26 over 60. Next is x is equals to 2, 2 squared is equal to 4, 4 times with the probability, that is 3 over 20. And then the last one is x is equals to 3, 3 squared is 9. So 9 times 1 over 60. And then you just have to subtract with EX squared, that is 47 over 60 square. Okay, don't forget the square. The next part is just computation. Computing these values, you should be getting 2051 over 3600. And how do you get marks on this question? You will get the first mark when you are using appropriate variance formula using EX squared. So they want to see you incorporate the value of EX squared into your formula. So on my part, I'll get my first mark here, M1. The next mark, which is my last mark, I got it when I get an accurate value of variance x, which is 2051 over 3600. That is an A1. Altogether 2 marks. I hope you understand my explanation, because we're going to move on to our next question. As what I mentioned earlier, when you see this question and you feel you would want to try it first, please do take a screenshot and come back to the video later to check your answers. Now this next question is coming from a winter paper on November 2024, paper 5.1. Now it is given to us that the random variable x, it takes values -2, -1, 0, 2, and 3. It is given that the probability of x equals to x. Remember, how do we read this? So basically the probability when x is equals to -2 is equal to, you can substitute the x with -2, right? And so on, where k is a positive constant. Question A, draw up the probability distribution table for x, giving the probabilities as numerical fractions. They want it into numerical fractions. They don't want an unknown to be there. So in the situation where you still have your k, you need to find out the value of k. As what you can see here, our x can take values of -2, -1, 0, 2, and 3. Now we need to write up the probability of each of them. Okay, what is the probability of x equals to -2? So think about this. Probability of x equals to -2 is basically k times with -2 square plus 2. This is basic algebra where you have to square the entire value given to you. -2 is the value, so you square -2. -2 square is 4. 4 plus 2 is 6. So it's equal to 6k. So the probability is 6k. This is in terms of k. What about the probability of x equals to -1? This is k times with -1 square plus 2. -1 square is 1. 1 plus 2 is 3. 3 times k is 3k. The probability of x equals to -1 is 3k. What about the probability of x equals to 0? If you substitute the same way as I did earlier, you will be figuring that this is equal to 2k. What about when x is equal to 2? Same thing, you will get 6k. And what about 3? You will figure that it is 11k. How do we find the value of k? One thing you need to remember is the probability when we add all together, it should equal to 1. So means that 6k plus 3k plus 2k plus 6k plus 11k is equal to 1. That is 28k. 28k is equal to 1. Means that k is equal to 1 over 28. Okay, k is 1 over 28. Now if I write all this probability with numerical fractions, then I should be having, I'll extend the bottom. Okay, now my probability of x equals to x would be 6 times 1 over 28. That's just 6 over 28. And then this is 3 over 28. And then this is 2 over 28. 6 over 28. And 11 over 28. Done. Alright, and how do I get marks on this? I have there altogether 3 marks. I'll get my first mark when I identified my k. In this situation, I identified k equals to 1 over 28 and it's right. So this is my B1. First mark, B1. My next mark would be from the table that is having correct outcomes and 2 correct probabilities. I have them correct outcomes. You just repeat the same outcomes given to you in the question. And then the correct probabilities, I have it here. So this is my M1. My last mark, which is A mark, will be given when I have everything fully correct. Okay? I have it here. So altogether, 3 marks. How's your work? Is it doing well? I'm glad if it does. Let's look at question B. Question B is again asking us to find the value of variant x. Do you remember what's the formula for you to find the variance of x? Again, let's write it down. Variance of x is basically the summation of x squared times p to be subtracted with the summation of x times p squared. So looking at our table, summation of x squared p would be, when our x is -2, x squared would be 4. 4 times 6 over 28. I'll write it down. Would be added with, when my x is -1, x squared would be 1. 1 times 3 over 28. And then when my x is 0, 0 squared is still 0, times with 2 over 28. Plus with 2 squared, that is 4 times 6 over 28. And then plus with 9, that is 3 squared, times with 11 over 28. And then I have to subtract all this with x times p, and then I have to square them at the end. So my first x times p would be -2 times with 6 over 28, to be added with -1 times with 3 over 28, to be added with 0 times 2 over 28, to be added with 2 times 6 over 28, and 3 times 11 over 28. Now don't stop there because we have to square the expectation of x. Now this next part is just pure computation. Computing these two lines, you should be having 150 over 28 would be subtracted with 15 over 14 squared. And that would give you 825 over 196. Why do I always write my answers into fraction? Because I would want to avoid truncation error. Fractions means I'm writing my answers with an exact value. I don't truncate the numbers, I don't round it up or round it down. That's what I'm trying to avoid. I'm trying to write my answers in an exact form. But it is still fine if you try to round it into 3 significant figures. Just make sure you don't make an error, okay? And how do I get marks on this question? I'll get my first mark when I compute the expectation of x, which is when I have this part over here. Okay, and when I am multiplying with correct numbers, so I have m1. The next mark is when I figure that variance of x is basically square of all my x's multiplied with the probability, and then I have to subtract with the ex square. So this is also an m1, the working of entire variance of x. My last mark, which is an accuracy mark, is when I have an accurate or correct variance of x. They would accept 4.21 or 441 over 146 or 825 over 196. So this is an A1. Altogether 3 marks. I hope you're doing well. Alright, let's move on to our next question. Now this question number 3 is taken from a winter paper still. It is winter 2024. Question paper 5-2. So again, if you would want to try before I explain, you can take a screenshot and work it out first. So question number 3. A fair coin and an ordinary fair 6-sided dice are thrown at the same time. The random variable x is defined as follows. Now, these require your attention and focus when you read the situation. Okay? It says here, if the coin shows a tail, then x is twice the score on the dice. Remember, we have a dice and a coin. All right, let me draw it for you. Okay, so they will be tossing the coin first. If they get a tail, then whatever on the dice will be times by 2. If they get a head on the coin, then x would be the score on the dice if the score is even. Okay, but what happens if it's not even? Then it would be 0. Means that it is not possible for you to get a head and then getting number 1, 3, and 5. Okay, because when you get an odd number, the score would turn into 0. You get it? Now let's take a while to think about what are the possible scores you can have. Our first situation, obviously you can have twice of the score on the dice, right? Which is 2, 4, 6, 8, 10, and 12. Maximum would be 12 because the maximum number you can have on the dice is 6. 6 times 2 is 12. Our second situation, which is when the coin shows a head, you are only able to get 0, 2, 4, or 6. Remember, it is not possible for you to get 1, 3, or 5 because your score would just turn into 0. So let's work out with all these outcomes. I'm going to erase my drawing over here. I'm going to make space for my table. Our x would be taking values from 0. We don't have 1, but we have 2. We don't have 3, but we have 4. We don't have 5, but we have 6. We don't have 7, we have 8. We don't have 9, we have 10. We don't have 11, we have 12. And what is the probability of each of those score turning up? What is the probability of you getting a 0? You are getting a 0 when you get a head and then when you get an odd number, right? So getting a head and getting an odd number. Getting a head, the probability is 1 per 2. What about getting an odd number? Odd number, there are 3 times appearing on 6-faced dice. So it's going to be 3 over 6 or 1 over 2. You multiply this, you should be having 1 over 4. I'll write there 1 over 4. What about the probability of you getting a 2? Probability of you getting a 2 is when you have a tail and on your dice is showing number 1, right? Because 1 will be multiplied to become 2. The probability would be 1 over 2 for you to get a tail and then 1 over 6 for you to get number 1 on the dice. This gives us 1 over 12. But don't stop there because there is one more chance. You see here? It is also happening here. It is happening when you have a head and getting number 2. So it is 1 per 2, getting number 2 on a dice, another 1 per 6. That is 1 per 12. So if you add this up, you will be having 2 over 12. What about the probability of you getting 4? Getting 4, the situation is just the same as you getting 2. Okay? So I'll write there 2 over 12. Getting 6 is also the same because it is happening here and there. So 2, 4, and 6, they are happening on both situations, which is 2 over 12. What about getting 8? Now, getting 8 is not happening when you're having a head. It is only happening when you are having a tail and getting number 4. Getting a tail and getting number 4, that is basically 1 per 2 times 1 per 6. That is equal to 1 per 12. Okay, I'll write here 1 per 12. What about getting 10 and 12? It's the same situation as you getting number 8. Can you think about it? I hope so. Now, please do check all your probability. Remember, all these probabilities should add up to 1. So if I try to add them together, I'll have 1, 2, 3, 4, 5, 6, 7, 8, 9. Now 1 per 4 is just the same as 3 per 12. From 9, 9, 10, 11, 12. Yep, I do have 12 over 12 altogether. That is equal to 1. So I'm done. And how do I get marks on this question? I'll get my first mark when I have a table with correct x values and at least 2 correct probabilities. So they would be checking if I have 0, 2, 4, 6, 8, 10, and 12. Those are the correct values of x and 2 correct probabilities linked. I have it here. I'll be getting my first B1. My next mark will be given if I have 4 more probabilities correctly linked to the correct x values. So I'll be having it here, 1, 2, 3, 4. They're all correct. That's another B1. The last mark is when all 7 probabilities are correct. And this is B1. If you are wondering what happens if you give the probability but not in the table, I mean, you calculate them all, right? You do have all this calculation for probability of x equals to 0 and you write it here. You have probability of x equals to 2 and you write it here. You have probability of x equals to 4 and so on. You write it here but not in a table. How much can you get? The answer is you can get maximum of 2 marks only. Because the first mark will be given when you have a table with correct x values and at least 2 correct probabilities. So if you don't have the table, you are not going to be given the first mark. But you can go for the second and the third mark. Okay? Moving forward, this question number 3 is also famous question I told you. It's asking you to find the variance of x. Remember what is the formula to find variance of x? Variance of x is just the summation of x squared times b to be subtracted with a summation of x times p squared, right? So each of the x you have to square and then you times with a p. Our first situation would be 0. 0 square is 0. 0 times with 1 per 4. Added with 2 square is 4 times with 2 over 12. I'm going to speed it up a little. You can just check your final answer afterwards. Okay? To be subtracted with x times p squared. Alright, the next part is just purely computation. You should be getting 420 over 12 to be subtracted with 54 over 12 squared, which is 59 over 4. And how do you get marks on this question? You'll get your first mark when you are working out for the EX. My EX is located here, and if you have all this value unsimplified but not just 4.5, okay, so they would want to see a working being done here. This is a method mark. Next mark is when you work for the variance of x, where you incorporate the value of your EX. That is another method mark. Last one is for correct final answer and accuracy mark. They would accept 14.75 or 14.3 over 4 or 59 over 4. This is an A1. Okay, I'll move on. This question number 4 is taken from, same thing, winter or November paper 2024, question paper 5-3. The situation here is a red fair 6-sided dice has faces labeled 111222, and then a blue fair 6-sided dice has faces labeled 112233. Both dice are thrown and the random variable x is the product. Okay, they are being multiplied of the scores on the two dice. So draw up the probability distribution table of x. If you are not able to imagine what are the outcomes, I would suggest you to work it out on an operation table. Operation table means that you're going to line up all those scores on one dice, and then you are going to operate with the other value on the other dice. So I have here 1, 1, 1, 2, 2, 2. On the other dice, I have there 1, 1, 2, 2, and 3, 3. Right? Now, because this is a product, I have to multiply all these numbers together. So 1 times 1, 1, 1, 1, 2, 2, 2, 1, 1, 1, 2, 2, 2. Now 2 times 1 is 2, 2, 2. 2 times 2 is 4, 4, 4. The same thing, 2, 2, 2, 4, 4, 4. This is going to be 3, 3, 3, and 6, 6, 6. 3, 3, 3, 6, 6, 6. Okay, so from there, you would be able to see that the least possible outcome is 1. And then the highest possible outcome is 6. So if you write in the probability distribution table, the possible values of x would be 1. You are also able to get 2. You can also get 3. You can get 4, but not 5. You see, 5 is not one of the outcomes. But you can get 6. Okay, and what is the probability of you getting a 1? Probability of you getting a 1, as you can see, that is 6 out of 36. Getting a 2 is 12 out of 36. Getting a 3 is 6 out of 36. 4 is 6 out of 36, and getting a 6 is another 6 out of 36. As what I mentioned earlier, if you can please add up your probability to see whether it sums to 1. In my situation, I have there 6, 6, 6, 6 plus 12. Yes, that is 36 over 36. That's 1. And how do I get marks on this question? I'll get my first mark when I have the table with correct x values and at least one correct probability. So I should have 1, 2, 3, 4, and 6 on my x values and at least one correct probability. Yep. So I get my first B1 here. Next mark I will get when I have 4 correct probabilities linked to the correct x values. So I have my first probability correct. This is going to be my second probability, third and fourth. That is another B1. Last mark is when I have all 5 correct probabilities linked to the correct x values. So this is the last mark, B1. Now question B is asking you to find EX. Now do not get confused with variance of x. EX is just the summation of x times b. Okay, you don't have to square this. Remember, on your variance of x, EX is located at the part where you are subtracting and then you square them. So variance of x is simply summation of x squared p minus with, what was it? Summation of xp, right? And then you square them. Now this part, I did mention on the first question, this is just your EX or your expectation of x. So how do you do this? You're doing this by just multiplying each values of x into the probability. So you're going to have 1 times 6 over 36 and then 2 times 12 over 36 and then 3 times 6 over 36 and then 4 times 6 over 36 and then 6 times 6 over 36. Computing this is just one mark question. You should be getting 3. How do you get marks on this question? You will get the mark when you get 3, but it is going to be follow through. So they are going to see if your probability distribution table has 4 or 5 probabilities that sums to 1, and then whatever values that you use from your table would be accepted. In my situation, I'll get 3, so that's my B1. Would you like to suggest the next topic? Comment below.
Hi, welcome to Misty's Math, your 9709 exam specialist. Now this video doesn't cost you anything, but perhaps for its support, you can click the subscribe button.